Okay, so we will now be doing our second exercise. James Bond Company wishes to assign a set of jobs to a set of machines. Now, the following table provides data as to the cost of each job when performed on a specific machine. So, our task here is A, to determine the assignment of jobs to machines that will minimize James Bond's total cost. And B, what is the total cost of your assignments? Now, we did the 3x3 matrix before. This one is a 4x4 matrix. So it's similar in nature, but it's just that you are now looking at 4 assignments. So let's go. Okay, you have the cost for each of the machines and for each of the job. So we are now going to follow our the assignment steps that we said. So we're going to subtract the smallest number. So we're going to be looking at the rows now. We're going to be looking at rows. Alright? So we're going to look at the smallest number in each row. So for first row, the smallest number is the 7. So we're going to put 7 from 7, 0, 7 from 9, 2, 7 from 8, 1, 7 from 10, 3. Good. So we now look at the second row, which is the 10, 9, 7, and the 6. So the 6 is the smallest. So you put the 0 here. 6 from 7, 1. 6 from 9, 3. 6 from 10, 4. So we go to the third row, which is the 11, 10, 9, and 6. And the 6 again is the smallest. So you put the 0 there. Then the 6, the 9, take away the 6, you get 3, the 6 from the 10, 4, and the 6 from 11, 5. So the fourth row now, 5 is the lowest, so you put the 5, the 0 there. Then 5 you subtract from the 9, you get 4. 5 you subtract from the 11, 6. 5 from that you get 3. Now, there are some assignments that from you do the rows, you reach the optimal solution, you know. There are some like that. So if you're lucky, you may get something like that. But most of the times, you have to now look at the columns, right? The columns. You have to look at the columns. So the next thing we're going to do is to look at the columns. What's the lowest figure in the columns? For this one here, the lowest is a 0. So you just put the 0, and once you get a 0, you just really rewriting everything else in here. Now this one, the smallest in that is the 2. So you put the 0 here at the 2. 2 from 3, 1. 2 from 4, 2. 2 from 6, 4. So the third column, and you have a 0 in there, so you're just literally rewriting the whole set of numbers. And you have a 0 in this already, so you put back the 3, the 0, 0, and 3. Now let us look and see how many lines can we take to cover all the zeros. You can say, okay, 1, 2, 3, 4. But is that the least amount? No, that's not the least. And you can say you go like this, 1, 2, 3, 4. But is that the least? No, that's not the least. The least is, if you go like this, 1, 2, and 3. See? 3 lines. So we have not reached the optimal solution. So it means now we have to go to the stage where we are going to be looking at the lowest number that is uncovered and do the same process that we did before. So we're going to look at the lowest number that is uncovered. And what is the lowest number that is uncovered? 1. Either this or this one, right? So we are going to look at the lowest number and subtract it from all the uncovered numbers. So the 1, we're going to subtract it from 4, you get the 3. Subtract it from the 1, you get 0. Subtract it from this one, you get 0. Okay, or the uncovered number, this 5, subtract it from that, you get 4. Subtract it from 2, you get 1. Subtract it from the 3, you get 2. Now, put back all the ones that are covered by the lines. So you put back the this, and this. 0, 0, and 1. That is covered by one line. So, and then you put back this one, it's covered by one line. 4, 4, 0. This and this is covered by one line. Now, those that are at the intersection, those are covered by two lines, which is this 3 up here and this 3 down here. And what did they say? That you should add that number, which is a 1, to the numbers at the intersection. So you get the 4 here and the 4 here. So once again, we're going to look and see what's the minimum number of lines to cover all of them. So we definitely need 4 lines now. So this is the optimal matrix. So this matrix is the optimal matrix that we are going to be using to make our assignments. Okay, and what did we say before? When we were going to make our assignments, you start with the one that has 1, 0 in there. So you don't even have a choice. So if we are going to be looking this way, rows, we can start with this. Let's see this one here. Let's start with row with this one for job 4. If you look, it's only 1, 0 in this one. So just tick this one. We're going to choose this one. Now if you choose this one for C, you're going to have to X out this one. You can't use this one again, because C, machine C, is already going to be used for job 4. Now this one, this is easy because it only has 1 as well. So we're going to be using machine D to do job 3. Okay, so if that's the case, we can't use this one again. So we look up here now, we'll go up now to 2. This one is gone already, that 0 gone already, that 0, that assignment gone already. So it's left just with this 1, 0 here now. So we're going to choose this 0. Now this one for B is already, can't use this again. So when you look now for job 1, this is the only one that's left. You see? So now let us write out the assignment. So the assignment, the answer now, would be, okay, job 1, we're going to assign to machine A. Job 2, we are going to assign machine B. Job 3, we're going to assign machine D. And job 4, we're going to assign machine C. So let us look and see how much this is going to cost. So let us go back now to the original matrix over there and tick off where these positions fall. So this was here. So that is 7. Job 2 is B, so that is 9 here. Job 3 was D, so that is 6. And job 4 there is C, so that is this 5 here. So I'm just going to transcribe them over to this side now. So A is 7. Machine B, that's 9. Machine D, that's 6. And machine C is 5. So when we add this up, we get 27. So 27 is the optimal solution, the cost. The total cost for the optimal assignment No, what we're saying that you can assign jobs to anything, you know, but if you want the optimal assignment, meaning it's going to give you the most efficient in terms of cost, minimum cost, this is the method you would use. Okay, now go and try some on your own. Thank you.